Okay, so welcome to section 7.3, which is vectors. Okay, so let's consider the x and y coordinate axes. X and y. Let's do I have enough room? 1, 2, 3, 4. 1, 2, 3. Okay, so 1, 2, 3, 4. 1, 2, 3. Okay, so let's have a point, of course, at 4, 3. So if I look at the line connecting this, do you agree that this radius is 5 because this is a 3, 4, 5 right triangle? Actually, let me be explicit about that. So it's 4 on the x-axis. And it is 5 on the y-axis. Sorry, 3 on the y-axis. Hence it's a 3, 4, 5 right triangle. Agreed? So the radius is 5. But what I want to do is I want to name this. I want to put a dot here and an arrow here now. So what I've done is this point here is called the initial point. Initial point of the directed line segment. Directed line segment. Because what have I done? I've created an arrow on this, so it's a line segment, but it has a direction. Hence, this point up here at 4, 3, where the arrow ends, is going to be termed the terminal point. Terminal point. Terminal point of the directed line segment. Of the directed line segment. Okay. So what about this angle? This, of course, makes an angle theta with respect to the positive x-axis. So do you agree if I were to create the triangle here, that this is a right triangle? So using the two sides I know, what do I have? Let's use orange. That tangent of angle theta will be the two sides that I'm given. I'm given x and y. So it's y, which is pink, 3, over x, which is purple, 4. Okay. So another way of writing that is theta is inverse tangent, if I want to isolate theta, of 3 over 4. Over 4. So that's the angle theta that this directed line segment makes with the positive x-axis. Okay. So let's note. The directed line segment from 0, 0, 0, 0 to 4 comma 3. Induces a direction, theta, made with the positive, x-axis as usual, x-axis, and has length, radius equals to the square root of 4 squared plus 3 squared. As usual, the Pythagorean theorem. Okay, so what is this directed line segment? Well, since this is a section on vectors, I bet you have a good idea. So definition. So a vector, that's what we're defining. A vector is a directed line segment. With both magnitude, which is another way of saying length, and direction. Which is angle theta, annotated by so vector v with what's known as a half arrow on top of it, and instead of using parentheticals, we now use angle brackets, x comma y. So by using the angle brackets, we're saying, okay, if I start at 0, 0, x comma y is where I end up, but I have to draw the whole line segment from 0, 0 to x comma y. So let's note. So it's not just the point, it's the whole arrow. So let's note. So a vector does not have a position in the plane. So a vector does not have a position, does not have a fixed position, in the plane. So for example, let's say I have x and y coordinate axes. Okay, like so. So x and y. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay. Actually, maybe I'll go down one more just for good measure. Okay, so let's say I have vector v given as 2, 3. So normally that means I start at 0, 0. I go over 2 and up 3, and that's where I end, and I'm pointing towards that point. That's my vector v. However, vector v can be anywhere. So let's say I start at this point. I still go over to the right 2, up 3. So this is also vector v. Oh, but let's say I start at this point over here. Can still go over to the right 2, up 3. This is also vector v. Or let's say I start down here. I go to the right 2, up 3. This is also vector v. Because vector v does not have a position. It just has a length and it has a direction. So the direction is always going to be with the horizontal. So each of these vectors makes the same direction, theta, with the horizontal. And you agree that the length is the same in each of these. Okay. So that is i.e. So beginning at any point. Beginning at any point. Point, let's say A comma B in the plane. Vector V equal to x comma y terminates at the point A plus x comma B plus y. And let's see if that's true. So the terminal point here is 2 comma 3. But let's say I start at 4 comma 2. The terminal point here is at 6 comma 5. So this is the point 6 comma 5. So is that equal to 2 comma 3? Actually, let me write it differently. So 2 plus, where's the point I started out for? Comma 3 plus, where's the place it started? 2? And it is, right? Check mark. Okay, so wherever I start, my vector is still there. 2 comma 3 is still there. I just add the coordinate where it started. So definition. Okay, so a position vector, that's what we're defining. A position vector. Position vector. V with initial point where it starts, not to where it points. So initial point x1 comma y1 and terminal point of course x2 comma y2 is given by, so vector v is equal to x sub 2 minus x sub 1 comma y sub 2 minus y sub 1. Okay, so some terminology. Let's do that in purple. Terminology. So given vector v is x comma y. So x is equal to the horizontal component. So therefore y is the vertical component. Meaning I go horizontal x and I go vertical y. From wherever point I start. Okay, so let's consider x and y coordinate axes. and y, and let's say I've got a vector, some random vector here, vector v. So let's say that vector v has terminal point A and B. Okay, so the point here, vector v, is given as A comma B, meaning, remember, angle brackets for the whole vector. And of course we have an angle theta made with the positive x-axis. So the length or magnitude of vector v is given by the square root of a squared plus b squared, right? It's just the radius. So a squared plus b squared, we know that. And the direction or angle theta of vector v is given by theta is inverse tangent of y, which in this case is b, over x, which in this case is a. Okay, so those are our magnitude and direction. So let me formally define them, or at least their notation, so definition. So number one, the magnitude of a vector v denoted by, so the way I denote it is double absolute values. So alternately, your book defines alternately a single absolute value, which I don't particularly like that notation. So is given by, well, we know that the magnitude is the length. So the magnitude of a vector v is just the square root of a squared plus b squared. Actually, of vector v equal to a comma b, otherwise that won't make any sense. Okay, it's going to be the square root of a squared plus b squared. That is a radius, or the length. And number two, the angle, of course, or the direction rather. So the direction of vector v being equal to a comma b, once again, of course, is given by so theta is tangent inverse, or inverse tangent of b over a. Okay, let's actually do an example of this, shall we? So for example, so find the magnitude and direction of the following vectors. So find the magnitude and direction of the following vectors. Okay, so number 1, let's say I give you that vector v is at -5, 5. So that's where it ends up, right? If I start at 0, 0. So let's first calculate the magnitude of vector v, which we know to be the square root of a squared plus b squared. So that's going to be the square root of quantity, -5 squared plus 5 squared. So that's 25 times 2, right? So this gives us a square root of 25 plus 25. So since I have two 25s, and I know the square root of 25 is 5, this is 5 square root of 2. And it should be a square root of 2, because of course that's a 45-degree reference angle. So theta, the angle or direction, is going to be inverse tangent of b over a. Okay, so that's going to be inverse tangent of b is 5 and a is -5. So this is inverse tangent of -1. Okay, now remember, normally tangent is classically invertible in quadrants 1 and 4. However, we need to note so v equals to -5, 5 terminates at -5, 5, which is in quadrant 2. So therefore, so theta, which is inverse tangent of -1, I know it's a 45-degree reference angle, but since I'm in quadrant 2, that's 135 or 3 pi over 4. Okay, so let's look at that. Let's plot this. So x and y coordinate axes. 1, 2, 3, 4, 5. X, 1, 2, 3, 4, 5. This is y. So I claim that vector v, let's do vector v in, what color shall we use for vector v? How about, if he starts at 0, 0, he ends at -5, 5. So this whole line with an arrow is vector v. And do you agree that vector v makes an angle of 135 degrees, 3 pi over 4? And it does. Okay, so that's the direction and magnitude or length of that vector. Okay, so let's do number 2. So let's say I give you that vector v is 3, -3 root 3. So now the magnitude, length, or radius will be the square root of a squared plus b squared, as usual. Okay, so that's going to be the square root of 3 squared plus the quantity, -3 root 3 squared. Remember, the parentheses matter because anything squared is positive. So this gives us a square root of 9 plus 9 times 3. 9 times 3. So really, I have 4 9s underneath there. I know the square root of 9 is 3, and the square root of 4 is 2. So the length should be 6. Okay, what about the angle? Well, the angle theta is inverse tangent of B over A. B is in yellow, and A is in purple. So this will be inverse tangent of negative 3 root 3 divided by 3. Get out, kitty. Okay, so we see that the 3's reduce. I know. So this becomes inverse tangent of simply negative root 3. So once again, we have to be careful. Which quadrant am I in? So let's note. Kitty pie. So note. Vector v being equal to 3 times minus or comma 3 root 3 terminates at the point 3 comma negative 3 root 3, and that's in quadrant 4. Okay, so I'm okay with that. So that'll just be negative the angle. So if I have theta is inverse tangent of negative root 3, that must mean that sine is the larger guy and cosine is the smaller guy. In other words, this is equivalent to saying negative root 3 over 2 divided by 1 over 2. So at what angle in quadrant 4 is the y-coordinate negative root 3 over 2 and the x-coordinate 1/2? Well, that's at an angle negative pi over 3. Okay, so let's make sure that that's true. So let's plot this. So x and y coordinate axes. X and y. Let's do 1, 2, 3. 1, 2, 3, 4, 5. So I know that my length is about 6. So I should be about here. So that's my vector v. So 3 root 3 is in between 5 and 6 approximately. I don't know. I don't use calculators. Okay. So is it true that this is negative pi over 3 here? This angle. And yes, it is. So we're okay with that. Okay, so let's do one more for this video. So number 3. Okay, so let's say I give you vector v is equal to, let's do negative 2 root 6, comma, negative 2 root 2. Okay, so the magnitude or length or radius, of course, is the square root of a squared plus b squared. Let's call this purple for A and yellow for B. Okay, so this is going to give us a square root of quantity, in parentheses, negative 2 root 6, all squared, plus, in parentheses, negative 2 root 2, all squared, Okay, so what that gives us is 2 squared is 4. So that's 4 times 6 plus 2 squared is 4. It's 4 times 2. So how many 4s do I have? 6 of them plus 2 of them is 8 of them. 8 is 4 times 2. So I can take out 4 times 4 times 2. So that's going to be 4 times the square root of 2. Okay, so my angle theta, of course, is inverse tangent of b over a. b over a. So this is inverse tangent for our cases. Oops. This is going to be, what do we have here? Negative 2 root 2 over negative 2 root 6. So of course the negative 2's reduce. So this becomes inverse tangent of root 2 in the numerator all over. Root 6 can actually be written as root 2 times root 3. Which means I'm once again able to reduce. So root 2's reduce. So now I'm left with inverse tangent, or tangent inverse, of 1 over root 3. And so you might think that that's in quadrant 1, because it's positive. But let's note the terminal point of vector v equals to negative 2 root 6, comma, negative 2 root 2 is negative 2 root 6, comma, negative 2 root 2, and that's in quadrant 3. So my angle theta has to be in quadrant 3. So theta, which is inverse tangent of 1 over root 3. So I can now force the 1/2 over the root 3 over 2, if you like, to make it more visible. So I'm going to call this negative 1/2 divided by negative root 3 over 2. So I'm looking for an angle in quadrant 3 where the y-coordinate is negative 1/2 and the x-coordinate is negative root 3 over 2. That's at 7 pi over 6. So that is my angle, or direction, rather. So that's my magnitude and direction for that vector. And I will see you guys in the next video.